When we simplify radicals, a lot of teachers have probably taught you how to do this throughout the years, and they all probably have a slightly different method. My method for simplifying radicals tries to make you do the least amount of work possible, because I know that you all like to be as efficient as possible and get it done without having to write a whole bunch of stuff down. In order to do this in the most efficient way, we need to know our perfect squares. So if you're in this classroom, the list of perfect squares is right there on the front board. If you are not in this classroom, here's the list of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you are at home, I would recommend that you write this list on a piece of paper and just have that out while you're doing these problems. If you're in my classroom, I will always have a list written on the board that you can reference, but it's also helpful just to have them memorized. Okay, so when we look at the square root of 18, we want to split this up. You can split up a radical using multiplication. So we want to split it into the square root of something times the square root of something else. But the first one, we want it to be from that list of perfect squares. So 9, we can definitely do 18 divided by 9. 9 times 2 is 18. Now, really, really important thing, because right now this is very simple, but we're going to get more complex. Like, look forward to number 6. It's going to get more complex, where some numbers have a radical and some numbers don't. At this step, both of your numbers should have a radical, a square root symbol over them. We can do the square root of 9. What is the square root of 9? 3. We cannot do the square root of 2, and we can't split it up anymore. The square root of 2 is some crazy decimal that keeps on going. So we now have 3 and the square root of 2. Our final simplified answer is 3 times the square root of 2. All right, now let's try number 72. Number 2, the square root of 72. Now, here's a potential problem. When I see 72, my brain thinks 9. But 9 is actually not the largest number on this list, and you want to get the largest number. So what I like to do is take the number and divide it by 2. Half of 72 is 36, and hey, 36 is on the list. So start by doing the number divided by 2, and then work your way down from there. That will make sure that you get the biggest number possible. So we want to split this into the square root of 36 times the square root of 2. The square root of 36 is 6. So our simplified radical is 6 times the square root of 2. Now, what happens if you don't find the biggest number? So here's this problem using 9. We'd split it into the square root of 9 times the square root of 8. The square root of 9 is 3. The problem is 8 is not fully simplified. Look up at this list. What can you split 8 into? 4 and 2. So then you end up with 3 times 2 times the square root of 2, which is 6 times the square root of 2. But you see how much more ink I had to use on that method compared to the method that I did originally. So you really want to get the biggest perfect square that you can divide out of that number. So next, let's try 48. Oops. Number 48, not number 48, square root of 48. What is half of 48? Half of 48 is 24, which is like here. It's not a number on the list. So I would try 16. I would try 48 divided by 16. And it works. It is 3. Square root of 16 is 4. So our simplified radical is 4 times the square root of 3.
Thank you.
Thanks. Number 4, we're going to start making this look a little bit more complicated. Basically, this doesn't change anything. We just need to save that 7 for later. Now let's look at the square root of 24. How can we split up the square root of 24? Half of 24 is 12, 9, 4. 4 times 6. The square root of 4 is 2. Now we need to think about everything that we have. We still have the 7 from up above, and we have the 2, and we have the square root of 6. The square root of 6, that 6 is known as a radicand. The 6 is a number that is stuck under a radical symbol. You can't multiply the 6 times anything else unless it is also stuck under a radical. 7 and 2 are both whole numbers or integers. You can multiply those together. So 7 times 2 is 14. We have 14 times the square root of 6. So you can multiply integers together. You can multiply numbers that are not under a radical. You can multiply radicands together, but you can't multiply an integer and a radicand together. So in number 5, I'm going to save the 2 for later, but I can multiply the 3 and the 12 together because they are both radicands. What is 3 times 12? 36. And by multiplying it together, we did ourselves a favor because the 36, we can take the square root of 36. So we now have 2 times 6, which is 12. What do you think you're going to do in number 6? You're going to multiply the 4 and the 3 together. You're going to multiply the square root of 18 and the square root of 10 together, and then simplify it. So why don't you pause the video and try number 6 on your own. So I multiplied the integers together. I multiplied the radicands together. I'm going to save that 12 for later and work on breaking up the square root of 180. So half of 180 is 90. 90 is not on that list. The first number on that list, smaller than 90, would be 81. So I would try to do 180 divided by 81, decimal. 180 divided by 64, decimal. 180 divided by 49, decimal. 180 divided by 36. Hey, that one works. The square root of 36 is 6. So ultimately I have 12, I have 6, and I have the square root of 5. So my final answer is 12 times 6, 72 times the square root of 5. All right, next we're going to get into fractions. Fractions are fun. Say that after me. Fractions are fun. They flat out refused. They refused to say fractions are fun. Come on, fractions are fun. Fractions are fun. We love fractions. Just like we love factoring. We love fractions. Okay, you can split up a radical using multiplication. You can also split it up using division. So this really is just the square root of 36 over the square root of 25. What is the square root of 36? What's the square root of 25? See, it's not that bad. Fractions are fun. Number 8, we have the square root of 75 over the square root of 36. Okay, square root of 36, I know that one. That's 6. Square root of 75, I'm going to go down here below and work on splitting that one up to get my final numerator. How can we split up the square root of 75? 25 and 3? Yep. So we have 5 times the square root of 3 over 6. Now, the 3 is stuck under a radical. So some people look at this and say, I see 1/2. 3 divided by 6 is 1/2. But that 3 is stuck under a radical, so you can't simplify that. Now, if this had happened to be something like 3 square root of 3 over 6, then this part could simplify because those are both integers, but you can't touch the thing under the radical. So this is our final answer. All right, number 9. Didn't want to let me move. Number 9, we have the square root of 6 over the square root of 5. Can we simplify either of those? No. Okay, so now we need to talk about something that's bad in math. Radicals on the bottom are bad. We cannot leave answers with radicals on the bottom. A radical, like the square root of 5, is an irrational number, and you cannot have an irrational denominator. So we need to do something called rationalizing the denominator. We need to get rid of the irrational on the bottom. We need to get rid of the radical on the bottom. Okay, side note. If I do like 5 times 1, what do I get? If I do 172 times 1, what do I get? So you agree that if I multiply a number by 1, I don't change the number. Okay. Another side note, what is 5 divided by 5? 1. What is 120 divided by 120? 1. What is the square root of 5 divided by the square root of 5? 1. I am going to multiply this thing by 1. But I'm not going to multiply it by normal, ordinary, everyday 1. I'm going to multiply it by this fancy version of the number 1. You all agree that the square root of 5 divided by the square root of 5 is 1, and you all agree that multiplying by 1 doesn't change the number. Okay, so here's what happens. On the top, we can do square root of 6 times square root of 5. That gives us the square root of 30. On the bottom, the square root of 5 times the square root of 5 becomes the square root of 25, which is 5. We no longer have a radical on the bottom. The math powers are like, oh yes, this is a much better answer. So number 10, there's no simplifying that we can do here, but this answer is not good. We need to get rid of the square root on the bottom by multiplying by a fancy version of 1. And that thing that is bad tells us what we need to multiply the top and the bottom by. On the top, we have 2 times the square root of 3. On the bottom, the square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? 3. So our final answer is 2 times the square root of 3 over 3. Number 11, we have a little bit of work to do. First of all, this is the square root of 45 over the square root of 32. So over here, kind of below this, I'm going to take the square root of 45 and see if we can simplify that. How can we split up the square root of 45? 9 and 5. So this is really 3 times the square root of 5. I'm also going to simplify the square root of 32. Half of 32 is 16. Hey, 16's on the list. So the bottom of this is 4 times the square root of 2. Now, most of this is fine. There's one thing in this answer that is not good. What is the one thing that is not good? The radical on the bottom, the square root of 2. That tells us what we need to multiply by. We're going to multiply the top and the bottom by the square root of 2. On the top, we have 3 times the square root of 10. You can multiply that 5 and 2 together. On the bottom, we have 4. We also have the square root of 2 times the square root of 2, which is the square root of 4, which is 2, so we have 8.